In this video, we're diving into the world of multi-tenant systems. This video will explain how to design scalable architectures that efficiently serve multiple customers, all while maintaining strict data isolation and robust security. So, what exactly is multi-tenancy? In simple terms, it's a software architecture where a single instance of an application serves multiple customers, also known as tenants. Think of it like an office building. You have one building, but inside there are multiple offices, each housing different companies. That's the essence of multi-tenancy: one application, multiple users. There are primarily three multi-tenancy models. First, we have the single-tenant model, where each customer gets their own dedicated instance of the application. Then, there's the multi-tenant model, where multiple customers share a single instance of the application. Finally, we have a hybrid approach, which combines elements of both single and multi-tenancy, tailored to specific needs. When it comes to databases, there are also different patterns for multi-tenancy. The first pattern is database-per-tenant, where each tenant has their own dedicated database, offering maximum isolation. Second, we have schema-per-tenant, which means the database is shared, but each tenant has their own separate schema, which provides a balanced approach. The third option is the shared schema, where all tenants share the same database and schema, which maximizes efficiency. Let's take a closer look at the shared schema implementation. The key concept here is that every table includes a tenant ID column. This column is crucial for isolating data between different tenants. For example, consider the users table shown here. You have the user ID, which is the primary key, then a tenant ID, followed by other user details. The tenant ID is essential for ensuring data isolation. In addition to the table structure, another critical aspect is data filtering. Imagine a function that retrieves user orders. It's crucial to always include the tenant ID in the where clauses of the query. So, it will look something like this: select all from orders table where the user ID is so-and-so and the tenant ID is such and such. This prevents data leakage, ensuring that each tenant can only access their own data. This is a critical rule. Always include tenant ID in where clauses to prevent data leakage. Security is paramount in multi-tenant systems. We have to consider two main aspects. First is data isolation, where we need to prevent cross-tenant data access through proper authentication and authorization. Second is access control, which involves implementing role-based permissions within tenant boundaries. Performance and scalability are also vital. One aspect is resource sharing. We need to ensure efficient use of compute, memory, and storage resources across tenants. Another aspect is dealing with noisy neighbors. We need to monitor and prevent one tenant from negatively affecting the performance of other tenants. To effectively manage a multi-tenant system, monitoring and observability are key. One important practice is tenant-aware logging. This involves including the tenant ID in all log entries. In addition to logging, tracking key metrics is important. We need to track per-tenant usage, performance, and resource consumption. This data helps in identifying and addressing any issues promptly. So, what are the key takeaways from this video? First, choose the right multi-tenancy pattern based on your specific isolation and cost requirements. Second, always enforce tenant-level data isolation in every query and operation. In conclusion, multi-tenant systems enable efficient resource utilization while maintaining security and performance for all tenants. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.